Fall protection working at heights guidelines. Overview. Utilize the following guidelines to evaluate your project for potential fall exposures and develop the safety controls necessary to address the exposures. All tasks involving fall protection will meet the requirements of OSHA, Occupational Safety and Health Administration, 29 CFR 1926, Subpart M Fall Protection. Summary. Applications. Guardrails. Hoisting areas. Controlled access zones. Fall restraint systems. Personal fall arrest systems. Safety monitoring systems. Holes. Overhead protection. Additional information. Applications. All employees exposed to fall hazards greater than 6 feet above a lower level will be protected by fall prevention or protection devices. Utilize the fall protection hierarchy of controls when determining the best method of fall protection. This will depend on the scope of the work. Hazard elimination. Engineering controls. Passive fall prevention, e.g., guardrails. Fall restraint, e.g., positioning device system. Personal fall arrest systems, e.g., tying off with full body harnesses. If fall protection is infeasible or creates a greater hazard, contact the safety department for assistance. Guardrails. Guardrail systems will be constructed of wood, cable, or engineered systems, such as switch rail. Guardrails must be free of projection hazards, e.g., protruding double head nails. When utilizing perimeter cable systems, cables will be installed between 39 to 45 inches above the poured slab. Cables can be at a higher height during steel operations, allowing for concrete. If the cables require a perimeter mesh, consider the following 2 techniques. 3 cables, top rail 39 inches 45 inches from the top of slab, mid-rail between the top and slab, and a bottom cable that attaches to the bottom of the debris net and acts as a tow board. 2 cables and a tow board that slides into channels. Pearl weave systems that use wooden blocks to attach directly to the slab often become damaged during the layout, deliveries of the enclosure contractors. 3/8 cable is typically easier to maintain than 1/2. The bottom cable can be 1/4. If mesh is not present on the perimeter cables, they should be flagged every 6 feet. Yellow duct tape typically lasts longer than pieces of caution tape. 3 clamps for each cable are required for perimeter cable. Plastic zip ties are less destructive to mesh than tie wire. Long runs between columns, stanchions may need intermediate stanchions to prevent deflection. Turnbuckles are useful at hoisting locations due to the ease in removal, tightening. Guardrail cables and guardrail systems are not to be used as attachment points for fall arrest or restraint unless engineered, designed, and maintained for that purpose. Prior to the removal or guardrails, a controlled access zone must be established. When guardrails are based on another working surface, e.g., perimeter scaffold, the distance from the edge of the slab to the top of the guardrail should be at least 39 inches. Hoisting areas. To address the various issues that can arise at hoisting areas, project teams should consider the following. While planning for coordination, establish locations of exterior hoisting areas as soon as possible. Perimeter cable turnbuckles and removable rail sections ease the removal, replacement process. Consider structural elements that can be used as fall protection anchor points. The following technique can ease the process of guardrail removal and prevent safety issues. A second set of removable guardrails and signage that encloses the hoist bay creates a corral that can be used by various employees, thereby minimizing the issues that can arise when isolating those areas. Controlled access zones. Controlled access zones, when created to limit entrance to areas where leading-edge work and/or other hazardous operations are taking place, should be defined by a barrier, e.g., guardrail systems, pennant flagging, jersey barrier, etc., control line that spans the entire length. Appropriate signage listing hazard and contact information. Control lines for roofing operations should be greater than 6 feet from the unprotected leading edge. Control lines for non-roofing operations should be greater than 15 feet from the unprotected leading edge. Employees inside the controlled access zones should take the proper precautions to ensure that everyone utilizes a compliant fall protection system. Fall restraint systems, positioning device systems. The restraint system should allow the worker to approach the exposed area, but not be exposed to a free fall. Fall restraint systems should be secured to an anchorage capable of supporting at least twice the potential impact load of an employee's fall, or 3,000 pounds. About half the weight of an elephant, whichever is greater. Contact the safety department for assistance with anchorage selection, connection devices, body harnesses, training, etc. Personal fall arrest systems. Each employee will be trained in the proper use and maintenance of that fall arrest system, anchorage selection, connecting device, body harness, etc. Reference the appendices for equipment inspection forms that can be utilized if needed. Any damaged equipment or equipment subject to a fall must be taken out of service. If a personal fall arrest system is used for fall protection, it should be capable of the following. Limit maximum arresting force of an employee to 1,800 lb. When used with a body harness. Limit free falls to less than 6 feet, unless designed for falls greater than 6 feet. Each component should support a load of 5,000 pounds. About twice the weight of a Clydesdale horse. Per worker, or be designed by a qualified person while maintaining a safety factor of 2. Self-retracting devices must meet applicable class outlined in ANSI, ASSPZ 359.14/2021. Safety monitoring system. When no other alternative fall protection is feasible or can be implemented and is required, a safety monitoring system can be utilized. Low-sloped roofs only and only for roofing work. The competent person will appoint a safety monitor and ensure that person is competent in the recognition of fall hazards, is capable of warning workers of fall hazard dangers and in detecting unsafe work practices, is operating on the same working surfaces of the workers and can always see them, is close enough to work operations to communicate orally with workers and has no other duties to distract from the monitoring function, will wear a reflective vest so she can be easily identified. No other employees should be allowed in areas protected by a safety monitoring system. All workers protected by the safety monitor should be instructed to promptly comply with fall hazard warnings issued by the safety monitor. Holes. Compliant fall protection systems should be utilized around holes, including skylights, that are 6 feet above lower levels. Floor openings 2 inches or more in diameter are to be covered, marked to identify a hole, and secured. Covers are to withstand 2 times the intended load. When guardrail systems are used at holes, all unprotected sides and edges should be protected. When the holes are used for passage of materials, the hole should not have more than 2 sides with removable guardrail sections. When floor openings must be made to perform work, e.g., trench work, raised access floor, etc., guardrail protection is required. Rigid plastic barricades, e.g., cones and stanchion bars or plastic jersey barriers. If a controlled access zone is set up, refer to Controlled Access Zone section above. Overhead protection. Whenever overhead work must occur on a project, the following items should be considered. The type of guardrail system used at the perimeter and around the openings, including toe board, debris netting, or other protection. Determine work practices and controls required for workers on scaffolds, aerial lifts, building perimeters, and other locations creating overhead hazards. When canopies are used as overhead protection, they are to be designed to prevent collapse, prevent penetration by objects that may fall upon the canopy, and meet applicable local codes. Weather and wind provisions. High-risk activity forecasting and planning. A high-risk activity, HRA, plan should be developed for tasks involving work being performed at heights. The following elements should be described as part of the Level 2 plan, which will involve a meeting 1 to 2 weeks before the task takes place. The identification of activities involving work from heights in the scope and schedule. The process to perform work at heights, including a job hazard analysis. Training and authorization requirements for those performing activities involving work from heights. Protection of work areas, fall protection equipment that will be used for the task, and personal protective equipment. Emergency plans, including an emergency rescue plan. On the day of the task, a daily hazard analysis will be completed, which should include required PPE, personal protective equipment, associated with the task, including fall protection body harness, type of anchor and type of connectors being used. Any previous near misses, incidents or lessons learned from the previous day's work. Change management process for changing site conditions. The steps for the task include the hazard and mitigation plan for those hazards. Crew sign in section. Additional information. OSHA 29 CFR 1926.5 Subpart M. Fall protection. OSHA Title 8 California Code of Regulations, 1504, 1660, 1662, 1663, 1664, 1669, 1670, 1671, 1704, 1710, 1712, 1716, 1724, 1730. Appendix A. Anchorage Connector Inspection Form. Appendix B. Horizontal Lifeline Inspection Form. Appendix C. Lanyard Inspection Form. Appendix D. Self-retracting lifeline and carabiner inspection form. Appendix E. Full body harness inspection form. Trigger heights and widths for fall protection and related issues in construction, 1926.